Hello everybody, this is the second part of the video about multiple spanning tree protocol. In this video I'm gonna review two types of MST misconfigurations. I'm gonna review them with practice, and I also want to review interactions between the MST region and the outside world, recommended configuration for MST, alternate configuration, invalid configuration, and the last one is going to be the rules how to get successful interaction. MST misconfigurations. With the new concept where the instance is independent of VLAN, the configuration must be planned carefully. There are two common misconfigurations within the MST region. First one, VLAN assignment to the IST, and the second, trunk link pruning. So I'm going to discuss these two in the further slides. VLAN assignment to the IST. For this example, we have topology on the picture where PC1 is connected to SW1 switch to interface G03, which is in VLAN 10, and PC2 is connected to SW2 switch on the interface G03, which is also in VLAN 10. And switches has two links between them. First link is on the G01 interfaces between switches, both of them G01 interface, and the second one on G02 interfaces. So this first link on G01 interfaces is in VLAN 20, and on G02 interfaces link is in VLAN 10. So both ports are in VLAN 10 and both ports here in VLAN 20. And VLAN 20 is mapped into instance 1 and VLAN 10 is mapped into instance 0. So this situation results in PC1 cannot communicate with PC2. This happens because MST information is conveyed with only IST BPDU, and individual instances do not send BPDUs. When switches exchange STP information for VLAN 20, they send IST BPDU with M record with instance 1 where VLAN 20 is mapped, but IST BPDU contains also information for instance 0, which means that IST instance is active on all ports inside MST region, regardless if these ports carry VLANs mapped to IST or not. So in this situation we have these ports are in VLAN 10 and these ports in VLAN 20, and as soon as VLAN 10, because VLAN 10 is mapped to instance 0 and instance 0 is present on all ports regardless of VLANs mapped to IST, this switch SW2 blocks G02 port because SW1 is the root bridge, and SW2 blocks a port which receives BPDUs with higher port number. G02 has higher port number, so this switch blocks G02 in interface. And this situation results that PC1 cannot communicate to PC2. To fix this situation, there are two options. First is more preferable. You need just move VLAN 10 to the MST instance other than IST to avoid mappings to IST instance. And the second one, allow those VLANs mapped to IST on all links. Let's try first misconfiguration when VLAN is assigned to IST instance. So we have two switches connected and two hosts. And for now, there is PVST protocol running, and this SW1 is the root bridge at the moment. So I'm going to change, I'm going to configure MST protocol and map VLAN 20 to instance 1 and VLAN 10 to instance 0. And this link G01 between switches is going to be VLAN 20, and G02 is going to be VLAN 10. So let's go. So spanning tree. Show spanning tree, and we can see that this bridge is root SW1, conf t interface, spanning tree mode MST, and spanning tree MST configuration. We have instance 1 VLAN 20, and I can skip configuration for instance 0 mapping VLAN 10 because it's already in there. So to show spanning tree MST configuration, and you can see that there is instance 0 and VLAN 10 is already there. So I'm just gonna exit to show spanning tree MST configuration, and you can see that we have now we have two instances, 0 with VLAN 10 and 1 with VLAN 20. I'm gonna give it name also, spanning tree MST configuration, name MST, and revision number 1. Then I'm gonna go interface. Let's see, I think I show VLAN. I already pre-configured VLAN 10 and VLAN 20 and G02 in VLAN 10 and G01 in VLAN 20. So what it is supposed to be for now for our configuration. And let's go to switch 2, show spanning tree. It's not MST, conf spanning tree, mode MST, and spanning tree MST configuration, revision number 1, name MST, instance 1 VLAN 20, and show VLANs. Let's see what we have. It's the same, VLAN 10 G02, VLAN 20 01, and show spanning tree MST configuration. We have two instances, 0 with VLAN 10 and 1 with VLAN 20. So let's go to our hosts. Host number 1, if config, it's 172.31.10.10, and if config 20. So let's try to ping 172.31.10.20. And there is no ping because we don't have connectivity. This is our misconfiguration. So if we go to switch 1, so spanning tree, we can see that all ports are designated for all MSTs, but we're gonna have blocking ports here. So G02 is in blocking, G02 where our VLAN 10, and G02 VLAN 10 is blocking, and all our hosts are in VLAN 10, so they cannot. We lost connectivity. We don't have connectivity because this port is blocked by MST. So to fix this situation, you can see also destination host is unreachable. To fix this situation, we have two options. First, we can change instance for VLAN 10 to, for example, instance 2, or we can make these ports as trunks. Let's go and see. Let's try first. Spanning tree MST configuration, instance 2 VLAN 10, and let's go to second one. Conf t spanning tree MST configuration, instance 2 VLAN 10. Now we have MST still blocking for this interface, G01 and G02. Let's wait a little bit. Forwarding, learning. This learning for host. Let's wait. Forwarding. What we have here, so spanning tree, forwarding. everything forwarding, but except this one. Page 0, 2, shut, no shut. G01 forwarding and G02 forwarding. So I had just to restart interface, and we should have ping T02 route forwarding, and yes, here we go, we have our ping. So let's go and change it back. Spanning tree, MST configuration, no instance 2 VLAN 10. Conf t spanning tree, MST configuration, no instance VLAN, no instance 2, sorry, VLAN 10. I'm gonna lost connectivity again. Blocking, in blocking, so we lost connectivity. As you can see, there is no ping, more ping running, so we're gonna see it now. Come on. And for now, I'm gonna make these two interfaces as trunk ports. So we lost connectivity, as you can see, and let's go and make these ports as trunks. Conf t interface range G01 2, no switch port access VLAN, no switch port mode access, switch port trunk encapsulation put 1Q, switch port mode trunk. Show run interface 01. Conf t interface 01, no switch port access VLAN 20, interface 02, and show run interface 01. Okay, and show run interface 02. Okay, show interface trunk. All good. And let's go to second one. Interface range G01, G01 2, range G01 2, switch port mode access, no switch port no switch port mode access, switch port trunk encapsulation .1Q, switch port mode trunk, switch port very good. Show run interface G01, conf t interface 01, no spanning tree, oh sorry, switch port mode access VLAN 20, and interface 02, no switch port 10. Run interface 01, it's okay, and 02, show interface trunk, all good. Show spanning tree. What we have in spanning tree, this one is blocking, and this one is blocking when we have traffic. T02 route forwarding from MST1, show spanning tree configuration, show spanning tree MST configuration. And we can see that we have traffic. Conf t interface 01, 02, shut, no shut. one shot, no shot, just to make sure that everything is fine. Show spanning tree. So G01 is in forwarding, and we have two VLANs allowed there, so it's working. We have connectivity between our hosts. Trunk link pruning. The topology in MST is determined by instance, regardless of the VLANs mapped to it. In this example, both VLAN 10 and VLAN 20 are mapped to instance 1, and if administrator decides to manually prune VLAN 10 on one uplink and VLAN 20 on another uplink in order to restrict traffic on the uplinks from SW3 to SW1 and SW2, the users on VLAN 20 will have a problem with connectivity. It happens because VLAN 10 and VLAN 20 are both mapped into the same instance 1, creating only one topology for both VLANs, and load balancing cannot be achieved here due to manual pruning, and that VLAN 20 is only allowed on blocked port. So here we have the administrator wants to achieve this topology where VLAN 20 is pruned from uplink from SW2 3 to SW1, sorry, and VLAN 10 is pruned from uplink from SW3 to SW2 switch. So he is gonna get some kind of load balancing, but because these both VLANs are mapped to only one instance one, and the topology in MST is determined by instance, we have the following logical topology where uplink from SW3 is blocked. Uplink from SW3 to SW2 is blocked. So in this case, we have VLAN 20 is blocked on this link by MST, and on this link it's pruned by administrator, so there is no connectivity from SW3 switch in VLAN 20 to both switches. And to fix this issue and achieve load balancing, VLAN 10 and VLAN 20 must be mapped to different instances. Never manually prune VLANs of a trunk. Remove all the VLANs mapped to the given instance together. Never remove individual VLAN from a trunk, and not remove all the VLANs that are mapped to the same instance. Let's review second misconfiguration example, and this is trunk link pruning. So in this case, we want, for example, to prune some VLANs on the trunk amp links to do kind of load balancing. So I'm gonna configure, for now there is PVST running on these switches, so I'm gonna configure it to MST, and I'm gonna map VLAN, both VLANs to instance 1, and then I'm gonna prune VLANs from these two uplinks to see where we're gonna lose connectivity. And I've pre-configured VLANs on all switches, and these interfaces to hosts are already in the corresponding VLAN. So this one is VLAN 20, this VLAN 10, 20, 20, 10. So let's go and see what we have. Show spanning tree. This is switch 1. It's a route for all VLANs. Conf T, spanning tree mode MST, spanning tree MST configuration, name MST, revision 1, instance 1 VLAN 10, instance 1 VLAN 20, and second, so conf t spanning tree mode MST, spanning tree MST configuration, name MST, revision 1, instance 1 VLAN 10, instance 1 VLAN 20. And let's go to the last switch, so spanning tree, all good. G02 is in blocking state for all VLANs. Spanning tree mode MST, spanning tree MST configuration, name MST, revision 1, instance 1 VLAN 10, instance 1 VLAN 20. Show spanning tree. So we can see that now we have also G02 in blocking state for MST0 and for MST1. Let's see if we have connectivity. PC3 is in VLAN 10 and it has this address, IP address, and PC1 is also in VLAN 10. Let's go to PC1. Ping. We have ping connectivity there, and PC4 is in VLAN 20 and PC2 as well. So ping connectivity, we have connectivity. Now I'm gonna go and prune VLAN 10 from this uplink and VLAN 20 from this. So interface G01, switch port, trunk, allowed VLANs. I'm gonna prune VLAN 10, so I'm allowing VLAN 10 and 1 and 20. And interface G02, 10. So for this, in this case, we're gonna lose connectivity in VLAN 10. Let's go and see. VLAN 20, we still have connectivity, and VLAN 10 seems we don't have connectivity. This is because I pruned VLAN 10 from this uplink, and it's only on this uplink from between SW3 and SW2. And as because we have one instance, and for that instance for IST this port is blocked, and it's blocked for all VLANs, so VLAN 20 is also blocked. There is no connectivity between this host and this host. There is no connectivity here on these links. So as you can see, there is no connectivity in VLAN. I'm sorry, in VLAN 10. So there is no connectivity between host PC1 and PC3 in VLAN 10. And let's go swap. So we're gonna prune VLAN 10 from G02 interface from this one, and VLAN 20 from this one. Interface G01, VLAN 20 pruned. So now we're gonna lose connectivity in for VLAN 20. As you can see, the VLAN 10 has restored connectivity, and we don't have connectivity in VLAN 20. And the same situation, VLAN 20 is pruned from this uplink. See, G01 only allowed 1 and 10 from this one, and it's only on this uplink. But because we have one instance, all VLANs are blocked on this port. So VLAN 20 is blocked. We don't have connectivity between PC2 and PC4. You can see destination host unreachable, and we have for VLAN 10. So never manually prune VLANs of a trunk. Remove all the VLANs mapped to a given instance together. Never remove individual VLAN from trunk, and not remove all the VLANs that are mapped to the same instance. So to fix this issue and achieve load balancing, VLANs must be mapped to different instances. So now I'm gonna map VLAN 10 to instance 1 and VLAN 20 to instance 2, and I'm gonna make SW1 root bridge for instance 1 and SW2 root bridge for instance 2. And I'm not gonna touch pruning for now. Let's see what we're gonna have. T, spanning tree, MST, configuration, instance 2, VLAN 20. And spanning tree, MST, VLAN, MST1, sorry, root primary, and MST2 root secondary. So this is going to be primary for first MST and secondary for secondary. Let's go to switch 2, instance 2 VLAN 20, and spanning tree MST1 root secondary and MST2 root primary. And let's go to switch 3, exit spanning tree MST configuration, instance 1 VLAN 10, instance 2 VLAN 20, and show spanning tree MST configuration. Okay, and let's check what we have now. Now we can see that G02 is still blocked for G02 interface for MST 0, and that's it. And we have connectivity in VLAN 10, and we have connectivity in VLAN 20. So let's go and see. G02 is root for the MST2, and G01 is root for MST1. So now we have load balancing, and that's what we were about to achieve in the beginning when we did this kind of misconfiguration by pruning VLANs. So as I said, never manually prune VLANs of a trunk. Remove all the VLANs mapped to a given instance together. Never remove individual VLAN from trunk, and not remove all the VLANs that are mapped to the same instance.
Interaction between the MST region and the outside world. With the migration to MST, administrators have to deal with interoperability issues between MST and legacy protocols. MST seamlessly interoperates with standard 802.1q, and Cisco also provides an efficient and simple compatibility mechanism between MST and PVST+. No MST BPDUs are sent out of the MST region, only IST BPDUs are. And internal instances MSTIs always follow the IST topology and boundary ports. So we have, in our example, we have VLANs 10 through 20 are mapped to the green instance only and allowed everywhere in the topology. So we can see this green instance in the BPDUs which are sent between switches inside MST region, and this green instance, all VLANs, they are allowed on these links between switches. Everywhere they are allowed on all trunks. Red links are IST and therefore CST. BPDUs for green instance are not seen out of the MST region. Only inside the MST region we can see these BPDUs with green instance. There is no loop in VLAN 10 through VLAN 20 as MSTIs follow the IST at the boundary ports, and the boundary port in SW2 also blocked for green instance. So this port is blocked, and there is no a loop in VLAN 10 through 20. Switches that run MST are able to detect PVST plus neighbors at the boundaries. They are able to detect that multiple BPDUs are received on different VLANs of a trunk port, for instance. And here we have interoperability issue when MST region interacts only with one spanning tree, the CST, outside of the region, but PVST plus switches run one spanning tree algorithm per VLAN and send one BPDU on each VLAN every hello time. The boundary MST switch does not expect to receive that many BPDUs. It expects to receive one or to send one, depending on if it is the root of the CST or not. To deal with this issue, a simple approach was created. The MST region replicates the IST BPDU on all VLANs to simulate the PVST plus neighbor. Let's review recommended configuration for interoperability between MST and, for example, PVST plus switches. So in this configuration, MST region is configured at the root bridge, which ensures that all region boundary ports flood the same IST instance BPDU to all the VLANs in the PVST topology. IST root needs to have higher priority than any other switch in the PVST plus topology. The MST region appears as a single entity, and the PVST plus switches detect the alternate links and place them into blocking state. The IST root is the root for all PVST plus instances on SW3, and SW3 blocks one of its uplink. So in our example, we have our MST region consisting of two switches, and we have SW3 switch, which is PVST plus. So in this situation, SW3 switch considers our MST region as a single entity, a single switch, which is a root bridge, and it blocks one of its uplinks, for example, this one. In this case, interaction between MST region and PVST plus is optimal. Port cost on uplink ports of SW3 can be tuned to achieve load balancing on VLAN by VLAN basis on each uplink, and uplink fast can be used as well on SW3 switch.
Let's try recommended configuration where MST region is the root. So we have the same topology that we had in the previous examples. We have three switches. At the moment they are running PVST, and I'm gonna configure SW1 and SW2 switch to run MST, and they're gonna be in the same MST region. And SW1 I'm gonna make as the root for all instances, and SW3 I'm gonna leave in PVST and see if we're gonna have connectivity between hosts. I pre-configured VLANs on all switches. They have VLAN 10 and VLAN 20, and these ports facing to hosts, they are already in the corresponding VLANs. For example, G01 interface in VLAN 10, and here G02 in VLAN 20. So let's go show spanning tree. You can see, and this is the root bridge for now for all VLANs, and this switch is running PVST protocol. So conf t spanning tree mode MST, spanning tree MST configuration, name MST, revision number 1, instance 1 VLAN 10. I'm gonna map both VLANs into the same instance number 1, and VLAN 20 also goes to instance 1. And spanning tree MST. Now I'm gonna make this switch at the root bridge for all MSTs. So we use 0 from 0 to 1, and we have two options, either priority or root. I'm gonna use priority, and then we gonna set bridge priority for 1096. And then let's go to switch SW2, show spanning tree. We can see that there is no MST, show run, spanning tree. There is PVST running at the moment, conf t, spanning tree, mode MST, spanning tree, MST, configuration, revision 1, name MST, instance 1 VLAN 10, instance 1 VLAN 20. So configuration is done. Let's check. Show spanning tree. MST 0 has a root port facing switch SW1, and MST1 the same, and we can see that G03 interface is boundary port, and it should be the same for this switch, for switch SW1. So G03 facing SW3 switch is boundary port for both instances. MST is okay, and let's go and see what we have on our switch SW3 where PVST is running. So we have G01 root port, G02 is in blocking state for VLAN 1, the same situation for VLAN 10 and VLAN 20. So run is spanning 3. Spanning 3 mode PVST. Okay, let's go and check if we have connectivity. As I said, PC1 and PC3 they are in the same VLAN 10, and the VLANs are already configured, ports are already configured, so we can just ping from PC1, we can ping PC3, we can see that we have connectivity, and we can ping PC4 from PC2. We have connectivity. Now everything is working, everything is configured. We have MST region on 2 switches, and we have interoperability between MST and PVST protocols. And as I said in the previous slide, that MST region is gonna send IST BPDUs to PVST switch with all VLANs. So let's go and check what we have on our switch SW3. Debugs. First I'm gonna change hello time to see BPDUs in more appropriate way. Conf T spanning 3 MST hello. I'm gonna change it to 10 and go see the bugs spanning 3, and then we have option BPDU and received. So let's see where are our BPDUs. Okay, they're coming. So what we have here, we received BPDU for VLAN 1 on G01 interface, for VLAN 10 on G01 interface, and for VLAN 20 on G01 interface. The same for G02 interface. So we are receiving BPDUs for our VLANs on our interfaces. So this is done. Thank you very much. Let's go to the next slide.
Alternate configuration, which is not recommended. In this scenario, all PVST Plus instances have a better root than the IST instance. In this case, PVST Plus is the core and MST is the distribution or the access layer. There are 2 cons of this scenario. First one, as MST runs only one spanning tree instance which can interact with the outside world, then boundary port can be blocking or forwarding for all VLANs, and there is no possible load balancing between MST regions, 2 uplinks, and PVST plus SW1 switch. Uplink on SW3 is blocking and on SW2 is forwarding. And the second one, this configuration still allows fast convergence inside the region in case forwarding uplink on SW2 fails. But switch over across the region is never as efficient as on the single switch.
Invalid configuration. Switch SW1 is the root for 2 PVST Plus instances except the red one, while switch SW3 is the root of the red VLAN. So we can see 2 IST BPDUs coming from SW1 switch, which is the root for them, and we can see red BPDU for red VLAN coming from SW3, which is the root for red VLAN. And uplink on SW3 switch to SW2 switch is in blocking state for all VLANs except the red one, because SW3 is the root for red VLAN. Designated for all VLANs except the red one, switch SW2 cannot block the red VLAN in case of the loop, as boundary port can only be blocking or forwarding for for all VLANs. MST region is only running one spanning tree with the outside world. In this case, when SW2 detects a better BPDU on its boundary port, it invokes BPDU guard to block it and place it into the root inconsistent state. The same mechanism makes SW1 switch to block its boundary port. Connectivity is lost, but a loop-free topology is presented. The rules to get successful interaction. The PVST Plus emulation check ensures that if an MST switch detects a better BPDU for a specific VLAN on a boundary port, the switch will use BPDU guard to block it and place it into a root inconsistent state. This may isolate downstream switches, providing a loop-free topology. The rules that help to get a successful MST and PVST Plus interaction are: first one, if the MST switch is the root, it must be the root for all VLANs. Second rule, if the PVST Plus switch is the root, it must be the root for all VLANs. That includes the CST regardless of the native VLAN when CST runs PVST Plus. And the last rule, the simulation will fail in case the MST switch is the root for the CST, while the PVST Plus switch is the root for one or more VLANs. It will put the boundary port into root inconsistent state. And link with useful information about multiple spanning tree protocol or 802.1s standard. I would like to say thank you for watching my video. I hope you enjoyed it, and please subscribe to my channel. I hope to see you soon. I wish you luck in your studying, and ciao ciao.